Greetings, Spartan fans. We are going to talk about ellipses today, so if you didn't get the note packet from the sub, be sure to do so now. Okay, so ellipses I think you're going to find to be way easier than parabolas. So by definition, an ellipse is the collection of all points in the plane of a sum whose distances from two fixed points called the foci. I know that's strange. It's the plural of focuses. Right, that's called the foci. Okay, so what happens is you'll notice that you have these 2 points, focus 1, F1, and focus 2. So imagine they're thumbtacks, and you have a piece of string that's being pulled along, keeping those thumbtacks in place, and the string is pulled taut around a oval, and that oval that is created is called an ellipse. There are some funky equations, and there's all kinds of letters. Don't let the letters overwhelm you. So you have this ellipse that has a center at the origin, and we have a focus at C, which is what we're going to use to represent the focal length. C is going to be where the foci are, and has vertices at a point negative A and positive A. And again, don't let these letters overwhelm you. I promise that they're going to hopefully make sense pretty soon. So on this ellipse, and you'll notice it's a fancy oval, the point here and the point here is called a vertex. And there's 2 of them, and they are called vertices. And then you have these 2 other imaginary points from the center. The center is HK. This is called a covertice, a covertex. The center is HK. And so the equation for this ellipse is going to be x minus h, hopefully you recognize the x and the h, squared, plus y minus k squared. So notice now we have 2 squared variables similar to a circle. But what's different is that I don't have a radius. I have 2 different radii. We're going to have a squared and b squared. And another way to look at this, and your book doesn't use it very often, but I like to say that a is the x radius, so r, but now we're going to say r sub x for an x radius, and then there's a y radius. So the distance from the center to the vertex, oops, I don't know what just happened there, that is the x radius. And the distance going up from the center of this ellipse going up, that's going to be my y radius. And so your book refers to them as A and B. And then alternatively, you could rewrite this as x minus h over a quantity squared plus y minus k over b quantity squared. And it has to equal 1. By definition, it has to equal 1. Okay. And then for an oval, an ellipse that opens more in the y direction, where its y length is longer than its x length, the equation is going to be very similar. X minus h, but instead of saying a squared, I'm going to flip them. The reason why I like to use the x radius and the y radius, then it's like, who cares what's a and b? The x radius goes underneath x, the r radius goes underneath y, or the y radius goes underneath y. And again, this could be written as x minus. The reason I'm using a and b is because that's what your book tends to use. And so if you're confused or you're like looking online, some books use a and b, and some use the x radius and the y radius. Okay. A is always the radius of the longer axis, also known as the major axis. And B is always the radius of the shorter axis, and instead of saying that it's major, we're going to call it minor. So C is going to be the focal radius. And that's going to tell you the distance from the center of this ellipse to the focus. Okay, so what that means is you'll notice that there's two different equations. In the first equation, they have it as a squared minus b squared. And in the second equation, they have it as b squared minus a squared. Okay, I want you to keep in mind that for the find the focal radius, it is always the longer radius squared minus the shorter radius squared. Okay, so like this is a lot of different variables and a lot of different equations, but as soon as we graph one of them, I think it's going to be a lot easier to look at. Okay, so example 1 says analyze the equation 9x squared plus 4y squared equals 36. Okay, well the first thing you need to do is that it must equal 1. So I'm going to divide by 36. And I'm going to reduce that. So it's going to become x squared over 4 plus y squared over 9 equals 1. Okay, so my x radius is going to be 2 because this represents a squared or b squared, whatever. And then my y radius is going to be 3. I'm going to erase this. I don't want to use a squared. All right, so which is bigger? Is 3 larger or is 2 larger? Well, last time I checked, 3 was greater than 2, and 3 is associated with y, so the major axis is going to be y. So this ellipse is going to be taller versus, it's going to be vertically larger than horizontally. Okay, so the center of this ellipse, there's no shift. So the center of this ellipse is at the origin. There's no h, there's no k. Okay, great. So the center of my ellipse, I'm going to graph this, is going to be at the origin. My y radius is 3. So from the origin, I'm going to go up 3 and I'm going to go down 3, and that's going to represent my major axes, and the major axes, vertices. So the vertices are going to be at 0, 3 and 0, negative 3. The co-vertices, also known as the minor axes, the x radius is 2, so from the center I'm going to go 2 to the right and I'm going to go 2 to the left because that represents the distance from the center of this ellipse to the co-vertices. So that's going to be negative 2, 0, and 2, 0. Okay, so x is the minor axis. And y is the major axis. Okay, so now I'm going to draw this ellipse. And now what matters are the foci. So the foci are always going to be the major minus the minor. Okay, well my major axis in this case was y. My minor axis was x. So I'm going to do my y radius squared minus my x radius squared. And you'll know you did it backwards because if you get a negative, then clearly you got to turn the numbers around. So the y radius squared is 9. The x radius squared is 4. So C is plus or minus the square root of 5. This represents the distance from the vertices to the focus. No, sorry, the center. That's incorrect. And they always go on the major axis. So my major axis is Y. My major axis is Y. So here's my center. So I'm going to go up root 5 and I'm going to go down root 5. Okay, well, without a calculator, the square root of 5 is a little bit more than 2. Okay, so this is a little bit more than 2. So how am I going to plot these? I'm just going to approximate. So I'm going to go up a little bit more than 2, and I'm going to go down a little bit more than 2. And they need to be on the graph. So how do I write these as ordered pairs? As ordered pairs, that point is 0 plus or minus the square root of 5. And those are your foci. If x was the major axis, I would have gone root 5 to the right and root 5 to the left. And I know that y is the major axis because the y radius is greater than the x radius. All right, now let's look at one that's not centered at the origin. So now we're going to look at one with h and k being something other than 0. Okay, so 25 is more than 9. The 25 is associated with the x, so this is going to have x is going to be the major axis. Okay, x is horizontal, so this ellipse is going to be longer than it is tall. My x radius is 5. My y radius is 3. And the center of this ellipse is going to be at 3, 1. H and K. So I'm going to plot the point 3, 1. Okay. From the center, I know that the x radius is 5. So from the center, I'm going to go 5 to the right, which doesn't fit, and I'm going to go 5 to the left. And then my y radius is 3. So from the center, I'm going to go up 3, and I'm going to go down 3, and I'm going to plot my points, and I'm going to draw an ellipse. Make sure you're using proper notation and proper vocabulary. Okay, so my vertices. From the center, I'm going to go 5 to the right. So that's like here-ish. I'll make sure that you have one that fits on the graph. So that point is going to be 8, 1. And I'm going to go 5 to the left. And that point is going to be negative 2, 1. Okay, so notice that my x radius, the center was at 3. So I did 3 plus or minus the x radius. The co-vertices are on the y-axis, and my y radius is 3. So from the center, I'm going to go up 3 and down 3. So that's going to be 3, 4, and 3, negative 2. Okay, and so then notice my y coordinate of my vertex was 1. So I did 1 plus or minus 3. And that's how I got the y values of negative 2 and 4. Okay, and now come this foci. Okay, so I got to find this value of c. Always the major minus the minor. So my major axis is 25 minus the minor axis, which is 9. That's going to equal c squared. So I believe that is plus or minus 4. So from the center, I'm going to go 4 to the right and 4 to the left. Why am I going right and left? Because x is the major axis and right and left represents x. So let's see, 4 to the right and 4 to the left. On the x-axis, well, the shifted x-axis. And now I'm going to draw this parabola. No, sorry, not parabola, ellipse. The foci are part of the graph. You need to put those 2 points in. And they also are an ordered pair. So my foci are going to be at 7, 1 and negative 1, 1. Okay. Now we're going to write the equation working backwards. All right, here we go. So we're going to find the equation of an ellipse with a center at negative 2, 4, a focus at 1, 4, and a vertex at negative 7, 4. Plot the points, and then one thing I think is super helpful is to figure out the major axis. So what I really need to know is the x radius, the y radius, and then I need to know c. Okay, so the center is at negative 2, 4. And then I know that a focus is at 1, 4. Okay, so from the center to the focus, that's my C, and I believe that is 3. It also tells me that X is my major axis, because to get from the center to the focus, I move to the right. And then I'm given that the vertex is at negative 7, 4. So negative 7, 4 is like here somewhere. Okay, this tells me that my x radius is 5. So the center is at negative 2, 4. So that's going to be x plus 2 squared plus y minus 4 squared. And that's going to equal 1. And I have to do something in the denominator. Okay, well, if my x radius is 5, then I know I'm going to have x plus 2 squared over 25 plus y minus 4 squared over something. I got to figure out what the y radius is, and that's going to be 1. Okay, so major, 25, minus the minor, which I don't know yet, is going to equal to c squared. Well, c squared is going to be 9. So 25 minus whatever that r sub y is. Subtract 25, divide by negative 1, you get r sub y, the y radius squared, is 16. So my final equation is x plus 2 squared over 25 plus y minus 4 squared over 16 is equal to 1. Okay, putting it all together. Parallel to the x-axis, that means that it is longer. Parallel to the y-axis means that it is taller. The equation, x minus h squared over a. I'm using a and b because that's what your book uses. I really prefer using r sub x and r sub y, but whatever. And then if it's parallel to the y-axis, I just think using r sub x and r sub y is just easier because then you have to remember, where does A go? Where does B go? Just remember, whichever one's bigger is the major, whichever one's smaller is the minor. And that is ellipses.